Voyager 1, launched by NASA in 1977, has become one of the most celebrated and iconic space probes in the history of space exploration. It stands as a testament to human ingenuity, embodying the relentless pursuit of knowledge and the deep-seated curiosity that drives our species to explore the unknown. For over 4 decades, Voyager 1 has been traveling through the vast expanse of space, gathering invaluable data about the universe and sending it back to Earth. The spacecraft's mission has not only expanded our understanding of our own solar system but also pushed the boundaries of what is possible in space exploration. However, in November 2023, a mysterious and troubling event shook the foundations of NASA's confidence in the probe. Voyager 1, which had been performing flawlessly for so long, suddenly sent nothing but an incomprehensible stream of 1's and 0's. For months, the spacecraft transmitted nothing but garbled data, creating a sense of panic at NASA. Had the longest-traveling probe of all time finally met its end? Was this the moment that the probe, which had traveled 22 billion kilometers from Earth, had given up? Voyager 1's extraordinary journey has already far exceeded the expectations of its creators. Initially, when the probe was launched, it was designed with a mission duration of just 5 years. No one could have predicted that it would not only survive for decades but also continue sending valuable data from the farthest reaches of space, far beyond the planets it was initially sent to explore. Since its launch, Voyager 1 has sent back breathtaking images and crucial data about Jupiter, Saturn, and the moons of both planets. Its observations have radically altered our understanding of these distant worlds. The probe provided the first close-up images of Jupiter's Great Red Spot, revealing that it is a massive storm in constant motion. It also captured images of the volcanic moon Io, showing active eruptions that demonstrated that other celestial bodies in our solar system could be geologically active. These observations helped solidify Voyager 1's place in history as one of the most important space missions ever conducted. The spacecraft's mission, however, didn't stop with the outer planets. As Voyager 1 continued its journey, it passed beyond the influence of the Sun's protective heliosphere, entering the uncharted waters of interstellar space. It became the first human-made object to venture beyond our solar system. This achievement not only marked a milestone in space exploration but also opened up a new frontier for scientific research. The interstellar medium, this vast, mostly empty space between the stars, had remained largely unexplored, and Voyager 1's observations would provide humanity with its first glimpse into this mysterious region. Voyager 1 is now providing scientists with the first direct measurements of the plasma, magnetic fields, and particles that fill interstellar space, offering critical insights into the makeup of this unknown frontier. Despite its monumental success, Voyager 1's communication systems are under constant strain due to the incredible distance between it and Earth. The spacecraft uses a radioisotope thermoelectric generator, RTG, to power its instruments and transmit data back to NASA. These generators convert the heat from the decay of plutonium-238 into electricity, providing the probe with a steady, albeit slowly diminishing, energy supply. As the years go on, the amount of energy Voyager 1 can generate continues to decrease, and its ability to power its instruments and maintain communication with Earth becomes more challenging. Despite this, scientists had hoped that Voyager 1 would continue to operate well into the 2030s, perhaps even until 2040, giving humanity more time to learn from the probe's incredible journey. However, as November 2023 approached, all of that seemed to be in jeopardy. When Voyager 1 suddenly began transmitting strange and seemingly meaningless data, the possibility of a catastrophic failure was too great to ignore. The probe had encountered issues before, but the severity of this new malfunction was unprecedented. The 1's and 0's that filled the data stream made no sense. To the untrained eye, they appeared to be nothing more than a random jumble of information. However, even the best decoding machines and human experts at NASA were unable to make sense of the signals initially. Was it a glitch? Was the spacecraft's memory corrupted? Or was this the beginning of the end for Voyager 1? For several months, it seemed that the probe's mission had reached its conclusion. Researchers were preparing for the worst, planning for a future without data from Voyager 1. Yet, just when it seemed that all hope was lost, the unexpected happened. In early April 2024, after months of uncertainty, Voyager 1 began transmitting usable data once again. It turns out that the strange stream of 1's and 0's had not been a sign of malfunction or failure, but rather a complex imprint of the probe's memory system. The data was encrypted in an unusual way that had made it nearly impossible to decipher at first. With the help of a dedicated employee working in NASA's Deep Space Network, which supports the communication of all spacecraft exploring our solar system and beyond, the data was decoded, revealing a wealth of valuable information. This remarkable recovery was a significant victory for the team at NASA and proved that even in the most difficult circumstances, the probe was still capable of transmitting meaningful data. This breakthrough allowed the Voyager 1 mission to continue, with researchers eagerly anticipating what new insights would emerge from the spacecraft's ongoing journey through interstellar space. One of the most fascinating aspects of this entire ordeal was the data that Voyager 1 had been transmitting just before the failure occurred. Scientists had been monitoring the spacecraft's measurements of plasma density and magnetic field strength in the interstellar medium, a region that was still largely unknown to humanity. These measurements, which had been gathered for many years, had already provided valuable information about the nature of space beyond our solar system. The interstellar medium, as it turns out, is far more complex than scientists had previously imagined. When Voyager 1 transmitted its strange signal in 2023, it indicated an unexpected surge in particle density. The intensity of the signals was unlike anything seen before. For researchers, this presented an intriguing mystery: what could be the source of this unusual activity? In the vast emptiness of interstellar space, scientists had expected the density of particles to be low. The Sun's heliosphere, a protective bubble created by the solar wind, shields the planets of our solar system from the harsh environment of interstellar space. Beyond this boundary, particle density drops dramatically, and the region is much emptier than the space inside our solar system. Scientists had always assumed that the interstellar medium would be a sparsely populated void, with only a handful of particles per cubic centimeter. However, the data sent back by Voyager 1 suggested that the particle density in the interstellar medium was much higher than expected. This revelation challenged previous assumptions and opened up new avenues for scientific exploration. The density of particles in the interstellar medium could have significant implications for our understanding of the cosmos, including the behavior of stars, the formation of galaxies, and the nature of dark matter. The strange stream of particles measured by Voyager 1 in 2023 sparked a wave of speculation among scientists. Some suggested that the intensity of the signal could be the result of an interstellar flare, an event similar to a solar flare, but occurring in the vast emptiness of interstellar space. Such a flare could be caused by the magnetic activity of distant stars, but its reach would have to be vast to affect Voyager 1, which is currently located billions of kilometers away from the Sun. Others theorized that the unusual signal could be the result of a previously unknown force at work in the interstellar medium, one that had never been observed before. The possibilities were endless, and the scientists at NASA were left with more questions than answers. Some even went so far as to speculate that the strange signal could be an attempt at communication from an extraterrestrial civilization. The notion that an alien intelligence might be responding to Voyager 1's journey through the cosmos was an exciting, albeit speculative, idea. Given that Voyager 1 carries a golden record, a compilation of sounds and images from Earth intended for any potential extraterrestrial discoverers, the idea that it could receive a response from an advanced alien civilization sparked the imagination of many. However, while the idea of alien life is tantalizing, it remains highly speculative. At present, there is no evidence to support this theory, but the idea that Voyager 1 could somehow be communicating with extraterrestrials is one of the many mysteries that make its mission so captivating. As Voyager 1 continues its journey through interstellar space, it is important to remember that it is not the only spacecraft on this incredible adventure. Voyager 2, its twin, was launched just a few weeks earlier in 1977, and its trajectory was quite different from Voyager 1's. While Voyager 1 took a more direct path, passing through the asteroid belt and heading straight toward the outer planets, Voyager 2 followed a more circuitous route, using flyby maneuvers to gain additional speed and explore different planetary bodies. Despite these differences, both spacecraft accomplished their primary mission objectives and have continued to send data from the farthest reaches of space. In 2023, Voyager 2 also faced a series of technical difficulties that had NASA engineers worried. However, just as with Voyager 1, the team was able to restore the probe to normal operation. Since August 2023, Voyager 2 has been transmitting data once again, providing valuable insights into the outer reaches of our solar system and beyond. The two spacecraft, despite their distance from Earth, are still an integral part of NASA's space exploration efforts. Their ability to transmit data over such vast distances is nothing short of miraculous, and it serves as a reminder of the incredible technological achievements that have made these missions possible. Both Voyager probes continue to send data back to Earth, and their missions are far from over. While their power supply may eventually dwindle, scientists hope that the probes will continue to operate for several more years. Even after communication is lost, however, the Voyager spacecraft will continue their journey through the cosmos. They are virtually indestructible, and their data will remain an invaluable resource for future generations of scientists. In the event that one of these probes is ever found by an alien species, it will carry with it a golden record, a time capsule that contains sounds, images, and information about humanity. The golden record includes recordings of Earth's natural sounds, such as birdsong and the sound of ocean waves, as well as musical compositions from artists like Beethoven and Mozart. These records are intended to serve as a message to any extraterrestrial civilization that might encounter them, offering a glimpse into the world of humans and the planet they call home. As Voyager 1 and Voyager 2 continue their journeys through the stars, they will undoubtedly continue to provide new and exciting insights into the nature of the universe. While their missions may eventually come to an end, their legacy will live on, inspiring future generations of explorers to venture out into the unknown. The story of the Voyager probes is a story of perseverance, ingenuity, and the insatiable human desire to understand the cosmos. It is a story that will continue to captivate the world for many years to come.